Water behind a dam is normally released at a rate of 250,000 litres per second. That's a lot. Find how long it takes to release 1 million cubic meters of water, which is, all right. So here's what we got to do. We got to convert this into litres. Yes. That was, now, what we're going to have to do is going to have to divide 1,000 meters cubed by we're going to actually have to multiply it by 1,000 to turn it into litres. So it's not a million, is it? And how many zeros am I going to have now? 6 zeros on the top one and 3 zeros on the bottom one will give me how many zeros? Or 9 zeros, right? And to be honest, I'm so groggy today, and you might be on the day of your leaving cert. I don't even trust myself, so I'm just. Ready? So there we have 9 zeros, don't we? So that's it there. Now we're going to divide that by 250,000 because we can fill up 250,000 per second. Okay, so I'm just going to divide this number by 250,000. Is it 4,000, is it? So it takes 4,000 seconds. Now, I'm right, but if I don't read the question, I've lost marks. What does it ask me for? The nearest minute. How do I convert seconds into minutes? Divided by 60. So because I entered it in my calculator, you need to enter it on your page. And 66.67 minutes, which is 67 minutes. I'll go with that. Okay, let's move on. Due to heavy rainfall, the operators of the dam decided to increase the flow by 10% for 24 hours. Find how many meters cubed of water were released in that 24-hour period. Keywords: meters cubed, not liters. We go with that? 24 hours. And what happens anytime you see this? What happens anytime you see that there? Anybody know? Science mode. Remember we said it yesterday? Anytime you see that bit of written like that, it just means science mode. Go to your calculator. Go shift, setup, number format. You're going to enter yourself into science mode. And you see all the answers start to look a bit weird now. Okay. Now here's what we're going to do. How many seconds are in 24 hours is the first thing I need to find out. Okay, this is probably before I even hit science mode, to be honest, all right? So what's 24? 24 hours, yeah? And there's 60 minutes in every hour. And in every minute, there's 60 seconds. Does that make sense to you? I think it might be 84,600, but I'm just going off memory there more than anything. Or 86,400. I'm just going to turn it back into normal mode for a second. So what's it? 24 by 60 by 60? 86,400, yeah. We okay with that? Now, every second, how many liters are released? How many liters are released every second? Can anybody tell me? It says in part 1. Exactly. So what I'm going to have to multiply this by then? 250,000. Now, the deal is that's in liters. Do we want our answer in liters? No. We want our answers in meters cubed. So before I do that, I look back up and go, 1 meter cubed is 1,000 liters. Everybody cool with that? So if I divide 250,000 by 1,000, it's basically 250 meters cubed per second. Is that right? So I'm going to change that to 250, not 2,000, not 250,000. I'm now going to enter sci-fi mode now, or science mode. Shift, sci-fi mode. Science mode. 86,400 multiplied by 250, and it gives me an answer of 2.16 by 10 to the 7. 2.16 by 10 to the 7 meters cubed. Does anybody know what significant figures are? Anybody remember? Do you want me to give you a quick reminder? Okay, so we'll start very basic. 42,000 is two significant figures. 42,100 is three significant figures. Is that right? 40. Can anybody tell me how many significant figures in this one? 40,003. There's actually 5, because if the zeros are sandwiched in between, they count. It's only when the zeros are at the end. Conversely, 43,000 is only 2. Everybody see that? Can everybody tell me what 40,300 would be? 3 significant numbers. Then when it comes to, yes? Oh, I have to increase by 10% at the end? Yeah, I'll do that in a second. Thanks very much. Sean just spotted something I did. I didn't increase by 10%. So I'm going to do that at the very end. Good job, Sean. Now, one more thing. If we go to decimal mode, are you ready? That's decimal mode. 1.2, how many significant figures? Just 2. 1.22. That's 3 significant figures. Okay. Now, let's go for this one. 1.03. Because the zero's in between, it's 3, isn't it? So how many significant figures do I have here currently? 3. But Sean rightfully said that I didn't read that it was increased by. I forgot. Actually, I read it and I forgot about it. So what had to do with this answer? Increase it by 10%. To increase it by 10%, I'll just multiply it by 110%. Is that okay? So when I multiply it by 110%, I get 2.376 by 10 to the 7. How many significant figures does this one have? 4. How many do I want? So 2.38 by 10 to the 7. So you go, Sean. Come on. Just the next question. Okay. John walks around a circular radius of 0.5 kilometers at a steady speed of 6 kilometers an hour. How long will it take him to do 3 circuits? So he's got to lap this 3 times. What formula gives you the perimeter of a circle? What page is it on? Page 9 of your tables, okay? And L equals 2 pi r. Are you cool with that? So it's going to be 2 multiplied by pi multiplied by 0.5. How many laps do we do? How many laps do we do? So we can multiply that by 3 all in one go. Okay, and then just lob it all into the calculator. So 2 pi times 0.5 multiplied by 3. I'm going. See that terrible answer there? We forgot to go back to normal mode, didn't we? Everybody see it? So go back to normal mode, shift, setup, number format, normal mode. Back to 1. Press equals again. And you just get 9.425. That's how many kilometers you traveled. How fast am we doing it? So DST triangle, distance, speed, and time. What one am I looking for? Time. Blank out time, and what do you have left? Distance divided by speed, okay? Now, this number here, 9.425 divided by 6. 1.57 hours, okay? And I'm going to go and press a button. What fancy button can I use? See this button here? What does that do? 1 hour and 34 minutes. 1 hour, 34 minutes. I'd almost be inclined to use 94 minutes. Does that make sense? So it says nearest minute. So, yeah, good. Move on. Mary decides to walk every day. Decides to walk every day for over a 5-day period. She walks a distance of 3 kilometers on day 1. She increases the length of her walk 15% each day for the next 4 days. Her average speed on day 5 is 4 kilometers an hour. Find out how long it would take her to complete her walk on day 5. Give your answer to the nearest minute. Oh, that's not too bad. Okay. So day 1, she's 3 kilometers. Yeah? How'd you find out day 2? What you got to increase it by? 115%. And that'll give you the answer for day 2. What about the answer for day 3 then? Multiply by 115% again. And that'll give you day 3. Multiply by 115% again. That'll give you day 4. And multiply by 115% again. And that'll give you day 5. Is that right with you guys? Now, you could do it the safe way. The safe way would be somewhere like this. You go 3 multiplied by 115%. That gives you your first answer, 3.45. Then you're going to multiply that by 115%. Okay. So that's the second time. So I did it once, didn't I? That's the answer for 3 days. That's the answer for 4 days. And this is the answer for 5 days. 5.247. A quicker way of doing it would be like this. How many times do I have to do it? How many times do I have to multiply by 115%? 4. So I can just multiply it by 115% to the power of 4. Is that right? That's adding on 15% 4 times. Be inclined to use my brackets. Same answer, isn't it? 5.247. Some use might also use decimals. How many use would have used 1.15 instead of 115%? That's allowed, and it would have been to the power of 4 as well. Okay. Now, it asked me how long does it take her to do her walk. She's doing 4 kilometers an hour. So we're going to get our 5.247 and we're going to divide it by 4. Distance divided by speed. So we'll get our 5. We'll divide it by our speed of 4. And then just press the change button. 1 hour and 19 minutes. Does that make sense? 1 hour, 18 minutes and 42 seconds. To show workings, I would just say 1.31 hours. And then I'd be inclined to press this button here then, and then say 1 hour, 19 minutes, otherwise known as 79 minutes. Is that okay with you guys? Okay. Any questions on that last one? One day, John walks, he meets Mary at point P. John is here, Mary is here. They're both walking in opposite directions. How far will he travel until he meets Mary again? Okay, this is interesting, all right? So, this is basically applied maths question. All right. First of all, who's going faster? Huh? John. So, first question I got to ask you is this, okay? This is a real problem solving one. They both won't meet on the other side of the diameter, won't they not? Why not? John will get there first. So what we're imagining is that John gets around past the halfway, and then Mary, who's here, she will meet John on her half of the circle, so to speak. Does that make sense? Now, John would have traveled this distance here in red, and Mary would have traveled this distance here. Does that make sense to you guys? Right. Now, distance equals speed multiplied by time. Would you be happy that John's distance is 6t? 6 kilometers an hour multiplied by the time he spends walking. What be Mary's one then? 4t. And would you be happy that 6t plus 4t has to equal the circumference of the circle? And what was the circumference of the circle? Oh no, that's when we multiplied it by 3. So it's only one lap, isn't it? So we'll just do this part here again. I think it's basically pi. Pi is your answer there. So it's going to be 2 times pi times 0.5. 3.142. Okay. 3.142. Very easy to sort this out now. 6t plus 4t. 10t, happy with that? 3.142. And then t equals what? Yep. I don't think many people are getting this one now. Okay. What do we want to know, the red line or the blue line? What do you think that means? Red line or blue line? How far will he, John, who's the faster person, walk before he meets Mary again? Need to know the length of the red line. And the length of the red line is 6 times t. So 6 multiplied by your answer you just got will give you how far he travelled. 1.8852 kilometers. And of course, I didn't get full marks for that. Can I explain why? I have it in kilometers. So how am I going to change that? 1,885 meters. Nearest meter, so 0.2 would have us round down. Okay, you guys? That's very difficult. Any other parts to this? Oh. Okay. We'll finish this off then, give you a small break, all right? Okay. Oh, is there another part? Oh, we're done. Perfect.